So in this video, we're going to continue topic 2.5, and we notice that we're going to kind of summarize what we have been doing in this topic so far. So we're going to start by writing the original function. Then we replace the f of x with y. Then we interchange, or we switch x and y. We solve for y, and then we replace y with f inverse of x. So we're going to go through those steps one more time here on example 8. So I'm going to start by saying that f of x is y equals 5 minus 3x over 2. Now I'm going to switch the locations of x and y. Now I'm going to follow in order of operations and reverse everything to get y by itself. So I'm going to multiply by 2. And then the next thing I would do would be to subtract the 5. So I have 2x minus 5 equals negative 3y. Now I'm going to divide by the negative 3. Now we would probably switch the y to the other side, but at the same time I'm also going to switch it back to f inverse, because if I start in function notation, I do need to end in function notation as well. All right, so the next part says if the point AB lies on the graph of f, then the point BA, so notice we switched x and y, lies on the graph of f inverse, and vice versa. The graph of f inverse is a reflection of the graph of f in the line or across the line y equals x. So we're going to talk a little bit about the graphs. So find the inverse function of f algebraically, and then use a graphing utility to graph both f and g in the same viewing window to describe the relationship between the graphs. They're probably using g as the inverse function. Okay, so I'm going to start by switching this to y equals 3x. And then I am going to switch the x and the y. And then I'm going to divide by the 3 to get y by itself. And I'm going to write it as, they said g, so I'm going to go with g of x, which we know is the inverse in this case, equals x over 3. All right, so now let's go into, I'm just going to go into Desmos just to graph it for you so you can see the relationship. So it's, our first graph was f of x equals 3x. And then our inverse graph is g of x. It's always a good habit to name your functions, divided by 3. And then you'll notice, let me just type in the line y, x equals y. So do you see how if I were to fold across the green line, that the red line and the blue line would end up on top of each other? So that's what you would, that's what you would, that's how you know it's an inverse function. For your homework, if it asks you to use a graphing utility, because of the nature of the way we're doing it, you could screenshot this very easily. So if you wanted to show me that you are actually trying it in your graphing utility. We are supposed to write down what the relationship is between the graphs. So we would want to say that the graphs are inverses of each other. Because they are symmetric across the across y equals x. Across y equals x, or you could say they're a reflection across that. All right, so let's try example 10. Example 10 is a little bit more exciting, a little bit different. So I'm going to start by switching it to y equals, and then we are going to switch x and y. I'm going to move the 1 over by subtracting. And we're going to undo the cube by taking the cubed root of both sides. So we would have y equals the cubed root of x minus 1. And then I'm going to switch it to function notation. I'm going to go f inverse because that just makes more sense to me than calling it g. It doesn't matter how you label it when you put it into your graph. So I'm going to go ahead and try graphing these. I'm going to leave that line y equals x. So we've got f of x equals x cubed plus 1. And then I'm just going to call it g of x, even though we called it f inverse. G of x equals the cubed root. I'm kind of foggy on where what I use for cubed root, but I know I can come down here and I can go to functions and miscellaneous maybe. There it is, the nth root power there. So I'm going to go cubed. That's not what I wanted. Control Z. The cubed root of, I don't know why I have an x on the outside, of x minus 1. And now look at it, and then, I lost my y equals x, so y equals x. So definitely folds or is symmetric across that line. Much more interesting graph. So you also want to make a statement about the fact that F inverse is a reflection of F across y equals x.